Good morning. I realized when I was listening to the keynote, I realized that I came here to learn. And I'm not disappointed from the keynote. I have already learned a lot. What I value in such conferences is the wealth of shared experience and kind of mutual learning that we can take from it. So when I was invited to speak on these conferences, I just wanted to make sure that to attempt to give back to the community for all those countless inspirations that I take from conferences like that. It may be that I will not be speaking about something new to you, but from my perspective, from our point of view, it was kind of a discovery on our path to organizational learning and thinking about what DevOps would mean to us. So in no way I try to say, or I will be trying to say that I am right in anything like this. It's just sharing what we have discovered. Culture eats strategy for breakfast. This is the sentence attributed to Peter Drucker, late management guru. We cannot be sure whether he said that indeed, but many people with established credentials in theory and practice of management do say so, and it is kind of a common wisdom that culture trumps strategy every time. Culture is powerful. It can amplify or kill almost instantly managerial efforts to implement organizational strategy. So for many people, DevOps is culture. Not a role name or function in the organization, but a culture that promises to bring development and operations well together in kind of a nirvana for those who are just sick and tired of this kind of traditional schism between those who build software services and run them. During my years of managerial work in software industry, I realized that even in organizations that hold their agile banners really, really high, there's no one understanding of DevOps. These differences happen not only between organizations, but actually they happen inside organizations. Every organization and department in the organization has its own challenges, its own culture and mindset. So depending on the point of view, DevOps can mean many, many things, like owning development to support tools like CI environments, seamless provisioning of needed infrastructure, easing the pain of monitoring the applications in production, or engineering reliability in the services. In this presentation, I would like to share how we, Ocado Technology, were discovering the meaning of DevOps for our organization and the direction that we currently take. As you can see, this was not a straight path, and I think that we have lots of learnings ahead of us. So, who of you have heard about Ocado or Ocado Technology? Okay, number of people. Not too many, but still. So, Ocado Technology is a software development division of Ocado, biggest online-only grocery retailer in the world. Ocado operates currently only in UK, and its business model is to sell food online and deliver to people's houses. Sounds very simple, but what is specific about a grocery retail market is that it heavily depends on the effect of scale and operates on high volumes. What counts is continuous elimination of waste and optimization of each stage of the process. In the online-only business, the profitability can be achieved only by application of computer systems and optimization algorithms. Our company grew on the continuous cycles of trying and learning, attempts to do something new. There's a saying that people learn from their mistakes, and wise people learn from the mistakes of others. It may look like we have chosen to make all the mistakes on our own, but actually, on the land that was not explored before, it is really hard to find someone to follow, to learn from. When you lead, it is really difficult to find someone to look at. One of the things that company learned very early in its history was that the software eats the world. And I promise this is the last eating analogy that I will use today. Also, the company realized that to benefit fully from this fact, it cannot just buy off-the-shelf stuff. It has to build its own software that addresses very specific needs of the company. We, as a company, provide end-to-end service with online and mobile e-commerce experience, automated supply chains, stock management, warehouse automation and control, delivery fleet, and customer care. So from e-commerce through backend systems, warehouse control, automation, routing algorithms, contact center, everything that powers Ocado is developed in-house. We have a couple of hundred people located in 5 offices in Europe. Our teams are co-located, autonomous, and have high level of responsibility for their systems. We aim for complete teams that are able to deliver with least possible dependencies. In our current model, development teams are responsible for designing, implementing, testing, deploying, and supporting their systems in production. We have learned to standardize important aspects of the process, and specifically for new systems that are cloud-based, we benefit from unified architectures and processes. But as we grew as a development organization, we realized that typical dev versus ops schism was hurting us more and more. Despite broad responsibilities of development teams and real effort of the infrastructure development and operations, these teams were finding, we were finding that these teams were becoming more and more bottlenecks in our organization. We grew in complexity of our systems. We grew in size and complexity of our organization. We became multi-site development center, or machine rather, and characteristics of the complex adaptive systems became very visible. Even cultural differences came into play. We needed to learn how to cooperate in the environment of increasing uncertainty with less and less knowledge about how other parts of the organization were developing. We became very aware that we will never have enough hands to do all the stuff that we would like to do. Despite you run an approach, reliability of our systems was not improving significantly, and a couple of outages that we had showed us very clearly that we had significant gaps in our operational knowledge about our systems. We experimented with embedding DevOps in various parts of organization, but with limited success. Additionally, we were faced with the growing frustration of development teams related to on-call. This responsibility was obvious for those who grew with the company, but new employees, people who joined us after the company grew to significant size, had less appreciation to quirks of the legacy systems. How many of you have read Google SRE book? Quite a number, but still, I think that I will have something new for you. You'll probably find many of these ideas in the Google SRE book, so I really recommend it as a reading. So this aha moment for me was when I read in the book that if we see the overall cost of running the life cycle of the system, of the application, 40 to 90% is actually generated by operational use of the application or development in production. So that was an important moment for me, because I realized that whatever millions of pounds we've spent so far to develop our systems, roughly the same amount or many times more we'll spend operating them in live production systems. It was a challenging perspective, because obviously we would like to minimize that cost. As we scale as a business, it is very important for us to not grow our operational effort linearly. We need to make sure that as we scale our business, our operational effort doesn't grow at the same pace. I also realized that our DevOps organic attempts were not enough. We were not growing our DevOps culture fast enough. So I realized that we needed something which I started calling growing engineering reliability capability. Engineering reliability will be used in this presentation more often. So when we think about the organization that develops something for customers, they such companies usually don't know what their customers want. They have some hypotheses, but what they really need, they need to try to actually discover what customers want. So what counts for such companies is their very fast feedback loop, the very fast cycle of stating the hypothesis and testing it against users, learning from it, amplifying or retiring results. According to Amazon, 1/3 of changes delivered to customers brings positive impact. In other words, 2/3 of changes delivered to production brings no results for customers or brings negative effects. So that's why the speed of learning, the speed of change, the speed of delivering change to production, the speed of learning about the customer is so hugely important. In such environment, it is very easy to forget that number one feature of the product is, can you tell me what it is? The number one feature of the product is that it works. And the number two feature of the product is that it works. If it doesn't work, customers cannot benefit from the fine usability experience or functionalities that solve their problems. It just needs to work. So if you have this if in your organizations you have this divide between so-called business and so-called IT, you probably experience already yourself this phenomena that the business always wants to have changes delivered faster. And they are not asking for reliability, and they will never do this, unless things go terribly wrong. It doesn't mean that they don't care, it's just not their primary focus. So it's usually IT that needs to appreciate and embrace that responsibility for making sure that things that we deliver, that changes that we deliver to production are working reliably. So I think that we all understand that reliability is a subject of law of diminishing returns. Finding the right balance between investment in reliability and investment in new features delivered to customers is a conscious decision. And creative mindset doesn't consider it most of the time. I have a lot of appreciation to frustration of business people and product managers if something that we deliver to production is breaking something else. I really sympathize with them. And yes, it is responsibility of our development machine to make sure that we don't introduce regression when we deliver something new. We have a number of techniques to do this, but as we know, this is not happening 100%. So it is worth to remember that both our organizations and our technical services are complex in their nature. Human organizations are complex adaptive systems by definition, and computer systems grow in complexity and reduced predictability over time. So in that context, I would like to share the insight that I had from the conversation with Wojtek Burkot, who was site lead of Google R&D office in Krakow at some point. He, as a physicist, kind of highlighted that we in software industry tend to forget that the universe has its kind of fundamental laws. And one of these laws is entropy. Entropy, that some people call measure of disorder, just grows universally. We can counter that growth by supplying energy. It can happen locally. But without that energy, disorder in any complex environment will only grow and ultimately cause things to fall apart. Entropy grows faster if the temperature of the system is higher. So if we think about the rate of change delivered to production by business, we can kind of draw this analogy between rate of change and temperature. So the faster rate of change, the higher temperature, and the more energy we need to invest to keep things together, to prevent system falling apart. The model of the service life cycle can be presented this way. The learning loop that I've spoken about happens most probably many, many times over the life cycle of the application. But this diagram emphasizes something else. It is easy to distinguish the design and building phase. This is when we design, write the code, test the application, set up infrastructure, install application, and so on and so on. This is there's this big ball of mud lands on the desk of operations, and they need to figure out how to operate this thing, how to run it in production, how to support it. In the product development organization, if the product development organization is significantly bigger than operations, then the natural consequence of this is that such handovers can happen multiple times, and operations gradually drown under the piles and piles of work that is kind of demanded from them. Does it sound familiar to you? I think there's also another interesting phase of this, that while the system is in production, then the system starts to change. So whatever operations learned about the system when it was handed over to them, this knowledge becomes obsolete very, very quickly. The system just changes. Some time ago, I have noticed that organizations are fractal structures. So you can find the same patterns on many stages, on many levels of the organization. So that realization helped me to see that not only in our organization, but probably in many organizations in the world, we have invested a lot of time in shortening the feedback loop on the building phase, while still have not invested enough in shortening feedback loop about the reliability of our systems. So, in attempt to make sure that we ship what was actually ordered, we try to create cross-functional teams, embed various skill set into teams, so we can really have this feedback loops very, very short. What the typical organization has also another feedback loop, which is critical for the future of the company, for the future of the service, but tends to be very, very long. And as the moment when it closes is called production launch. When I was reading about various aspects of management, I read W. Edwards Deming, who said that inspection doesn't improve quality, that the quality has to be built into the process of production. In the same way, we could say that reliability has to be built into this process of delivery. That late inspection at the production launch doesn't improve the reliability of the system. So we have to make sure that on every stage of the development process, we have measures to check, we have ability to check whether the increment of work is actually going to be reliable in production. So I started thinking about reliability mindset. I realized that in cross-functional teams, we have, for quite a long time, we've had only developers. Then we introduced test engineers. And the reason for this was that we noticed that developers test slightly differently than people who have this testing mindset. There was a difference between build it mindset, and break it mindset. Developers test happy path mainly. Testers are able to find gaps in our tests very, very quickly. They are able to prove that something is not done yet. So I realized that there is also a reliability mindset. The good way of testing it is to ask your team, how do you know that your service works? Or what is the average response time for your service? Or how many requests per second system handles in a peak? If you have this, if in response you see this kind of slightly confused facial expression, then you know that this reliability mindset is not there. Reliability mindset doesn't need customers to determine whether the service is down or latency significantly increases. People who have it know, even without looking at the monitoring tools that they have set up without being asked, what the response is, what the latency is, or what is the usual consumption of the database connection pools. We discovered that reliability mindset was represented stronger among managers who grew from the technical world, from teams, and had more relations to the business, so they could see reliability as their own responsibility. But on average, the average team's awareness of the productional or operational characteristics of the systems was, in my opinion, not enough. The system of work, recruitment process, business priorities, everything around those around teams incentivizes focusing on feature roadmap rather than number one feature that the product works. So we've seen many challenges. I will skip through them because I can see that we're a bit running out of time. But you probably can see, you can see things that will be familiar for you. So operations that are silo in the organization, that are bottleneck, that is not able to help themselves out of the work demand that is imposed on them. Technological diversity, unhealthy technological diversity that creates more and more cognitive demand on operations. The problem of knowledge transfer, which I've spoken already about. And scaling of the capabilities like incident management, like learning from the incidents from the past. So when we started developing the vision, where we would like to go, where we would like to be, we realized that we would like to create structures that would be parallel to dev, that would be kind of an immediate feedback loop for dev teams to give them instant information whether the change delivered to the system has the potential to be reliable in production. We wanted to break silos and introduce exchange information, exchange of experiences, personal relations between people who develop and people who can support systems in production. We want to create teams that will be equal stakeholders between dev teams, between operations, between incident managements, and teams that will be able to support systems. Reliability, we want to have reliability as a continuous effort that happens all the time in our organization because we have entropy. We want to have early involvement in the product life cycles, so we can, right from the beginning, can architect our systems to be reliable in production. We want manual work to be only a feedback loop that tells us whether we are successful with reliability engineering. We want focus on operational performance and the service and the unification of the tech stack. Growing with service, with product portfolio is also very important. Focusing on an area in the organization that would be that serves a very specific business need. In this presentation, I've spoken more about challenges we faced as a company, but I don't think these challenges are unique to us. Looking at the response from the organization about the proposal to implement SRE function in our organization, sometimes enthusiastic, sometimes skeptical, I think that we have very interesting time ahead of us. We have a mission and vision, and we have a understanding what would be the ethos of SRE function of reliability engineers. However, we cannot say this is about future, and future is inherently uncertain. I cannot predict whether we will succeed or not, but well, our CTO says that history favors those who are ready to get their feet wet. And this is the nature of our company, and we are not afraid to do this. We have just started our path on implementing SRE function. And as I said, I have no idea whether we succeed, but we are going to try it, and next year I will be happy to share our learnings. Thank you very much.